All right, we're going to look at these functions, but first let's look at what we're doing. So we want to find this area that's where I'll call this region S, so I don't just, use R all the time. So I'm going to begin by finding my points of intersection. I was half tempted to give you the real classical problem where I found both of these areas. Maybe we'll do that. That seems like a really, really good idea. And by inspection, I would hope that you could see it's this. Now, this region down here has the same area as region S. Okay. However, to find it, it's different. So we first start with putting our sample point. Now this sample point, we have an x and y is x. Draw this down here. We have an x and y is x cubed. So my height here, my dA, so to speak, is my top function minus my bottom function times the width. Now, if I was to deal with this one here and find it, notice it would be x cubed minus x, and that would force this height to be positive. But let's stay focused at the task at hand. The area of region S goes from 0 to 1 of x minus x cubed in x, which is now 1/2 x squared minus 1/4 x to the 4th from 0 to 1, which is now, when you do your substitution, 1/2 minus 1/4 minus 0, and you should have 1/4 of a square unit. Now let's take a look at, there it is right there. One way I could do this problem, and this is where the students with Inspires have an advantage. I'm going to use the bounded area command. It only works if you have two. So 0 and 1. Boom shakalaka. But Mr. Isaac, I have an 84. What do I do? Oh, okay. So you come over here, you get a graphs page, and you're just going to enter it. It was x minus x cubed. Okay. Now, let me do some zooming in. Zoom in. Wait a minute, that was zoom out. I want zoom in. Zoom in, please. Boom, 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 boom. Now, let me just change this. Now notice, here, this region S is up here. It's the area, oops, it's the area underneath this curve. So, I'm going to go analyze graph, integral, lower bound 0, upper bound 1. Boom. Now let's go back to the next task at hand, which is revolving this. Okay, this is a little sketch. Mr. Isaac, but this, hold on one second. But this isn't a disk. I know, it's really, I think of this as the disk method. It's just, if you really think about this, when you pull this sample point out, this is a y1, this is the same x value, different y value. You have a cylinder where you've taken a cylinder out. This big radius is x, this little radius is x cubed. So the area of the cross section is the area of the big circle, area big radius squared, minus, now I'm going to factor the pi out, small radius squared. So this is x squared minus x to the 6th. So dv is pi, x squared minus x to the 6th in x. So my volume of the solid of revolution, oops, I was off the screen and nobody said anything, is pi, the integral of x squared minus x to the 6th in x, and don't forget your bounds like Mr. Isaac. And so this is pi. X cubed over 3 minus x to the 6th over 6 from 0, 1. Okay. So if you think about this, this will be a third minus a sixth minus no thirds minus no sixth. Okay, that's a whopping 0. This is 2/6 minus a sixth. I hope that's still a sixth. Please don't forget the pi like Mr. Isaac. Now, let's go do this two different ways. The first way we're going to do this is we're going to graph our function, our cross-sectional area, or I should say, yeah, area function, really. Don't forget a parenthesis like I just did. And x to the 6th. Okay. And I am just going to, I want window, let's do zoom box. Okay, that'll work. Okay. Analyze graph, bounded area. Now the area underneath this curve from 0 to 1, wait a minute, why won't it? Okay, I hit the wrong button. Integral. 0, 1. Okay, let's get a few more decimal points of precision. Alright, now let's add, and let's do this symbolically. I don't like implied multiplication. We're going to go back to calculus class. We're going to get the definite integral. We're going to go from 0 I think that was f4 of x. We'll go check that in a second. We just won't hit. Okay, and now that's f4. So I can just use f4 there. Oh, wait a second. They can't. Well, let's double check this. Oh, I found a mistake. We're going to have to go back and fix something. Okay, see, I was going so fast, I made a mistake. The integral is set up correctly. However, I forgot to add a power to the second part of this fraction. So, it's from 0 to 1, x squared minus x to the 6th in x, which will be pi. This will be x cubed over 3, but I forgot to add, for some reason I thought it was x to the 5th. I don't know why. Okay. But see, we all make mistakes. 1/3 minus 1/7 minus, that'll end up being zeros. 7 minus 3 is 4 pi over 21 cubic units. Okay. So notice even I made a mistake, but I went back and fixed it. So where is my mistake? It's right here. This is x to the 7th over 7, which means I need to fix that, so I draw a single line through it. We all do it. Just take your time and fix them as you go. Come on.